Okay, so welcome back to another session of Technologies for Clean and Renewable Energy Production by Professor Mandal from IIT Roorkee. So this week, the main topics of the course is based on biomass and waste valorization. So last class we mainly focused on the renewable sources, mainly wind, solar, geothermal, tidal, etc. So this time, this week, the focus is based on energy from biomass and waste feedstocks. So in this week's topic, Professor Mandal will be going through three different routes of valorization of waste from biomass, mainly physical, chemical, and biological. So let us delve deeper into this week's content. So biomass and waste as a source of energy. So like in recent decades, at least for the last 20 years, if I am correct, we have been trying to valorize biomass. So biomass basically means anything that is from plants and in some cases animals as well. So for example, grass, corn stover, bagasse, wood chips. So these are all some examples of biomass. So basically residues, plant residues. So these things are generally called as biomass. So these examples that are shown here are basically examples of lignocellulosic biomass or lignocellulosic agricultural residues. And in these plant residues or biomass sourced from plants, the major constituents are cellulose, hemicellulose, and lignin. And the constituents of this cellulose, hemicellulose, and lignin will vary depending on the type of biomass. So, for example, if you take the bark of a tree, usually the lignin content in some barks will be higher. But then, if you take something like a leaf or a grass, it can have more cellulose and hemicellulose. So, depending on the source from where the biomass is sourced, the macromolecule content or the cellulose, hemicellulose, lignin distribution can vary. So yeah. So yes, biomass as a source as and waste as a source of energy. So this research is a recent one, maybe like 20 to odd year old. Not exactly sure, but 20 to 30, let's say. So people have been trying to develop different types of processes to harvest energy and various chemicals from biomass and other waste feedstocks. So yes, so that is basically what's the focus is on this week's lessons. So biomass, as I said, you can it's mainly plant residues, and depending on the source of biomass, the properties can also vary. So this is just a list of biomass feedstocks with along with its moisture content and its heating value or a calorific value. So you can see, papers, cardboards, and bags usually have a very low moisture content. Wood boxes, wood crates. So these all have moisture content less than 10%. And because the moisture content is low, they usually have a calorific value slightly higher than the other biomass. So somewhere between 15 to 20 megajoules per kg. But if you take something like garbage, this can include anything like food waste, plant or animal remains, etc. So usually these kinds of waste are seen to have more moisture content, and subsequently the heating value is also very less compared to other counterparts. So this is just a table briefing the amount of moisture content and the heating value of different sources of biomass. So biomass and waste, you have four different modes of converting the biomass and producing energy and chemicals. So first is the thermochemical conversion. So this basically means we provide heat in order to induce chemical conversion. So it can be combustion, gasification, pyrolysis, and liquefaction. And then you have biological conversion, basically using biological activity or microorganisms. So biological conversion can be anything like anaerobic digestion, fermentation, enzyme hydrolysis, etc. And then you have chemical conversion, wherein a chemical reaction happens through which the biomass and waste are converted into the different products. So something like a trans esterification process, or a hydrolysis, or solvent extraction. So these kinds of process are usually chemical conversion process, and then there is physical conversion. So this is only physical, no chemical change is induced in the feedstock. So usually, these things vary or change the physical properties of the biomass and feedstock. So something like densification, for example. So, for example, if we had like 1 ton of biomass or grass, let's say, we are taking grass as an example. So, if we had like 1 ton of grass that we want to transport somewhere, it's easy to transport it by densifying it, or like, compressing it into, smaller sized boxes, or, pellets, or even briquettes. And because it is now densified, basically meaning the density of that grass is now higher, and the size becomes very small. Transportation of that grass will be much easier, and because it is again densified, the energy density also increases. So yeah, we'll be just briefly going through this process anyways, but yeah, this is what is basically called as physical conversion processes. So these are basically the four different types of process that are followed. One second. Yeah. Okay. So these are the four different routes by which energy can be produced from biomass. And the first focus for us would be on a biological process known as anaerobic digestion. So basically, in anaerobic digestion, so we can have any kind of biomass feedstock, such as crops, energy crops, something like a jatropha, crops which are non-edible but high in energy density. So, or animal waste, like animal remains and animal feces and so on, industrial waste, municipal solid waste, food waste, and even sludge from wastewater treatment plants. We can use anaerobic digestion to convert all these different feedstocks into the major products, which can be biogas, or something like a methane mainly, and hydrogen, biofertilizers. So this is basically the residue from this anaerobic digestion process, compost, and even reusable water. So a series of biological processes in which microorganisms break down the biodegradable material in the absence of oxygen. So that is basically the definition of anaerobic digestion. So as I said, we'll be using microorganisms to break down the feedstocks, which are as listed here, in the absence of oxygen, in order to produce the products, which are mainly biogas and hydrogen, and fertilizer, compost, and water. Right. So this is just a flow sheet of how anaerobic digestion is carried out. So we have the organic feed, which is basically our biomass feedstocks or any waste feedstock. We introduce water and chemicals, and we shred and blend this process, and adjust the pH such that the feedstock is not too acidic nor it is too alkaline. And once all the shredding and pH adjustment, or basically pre-treatment of the feedstock is done, we then send it to a digester where anaerobic digestion happens, and then we have all the gas that comes out, and the effluent or the bottom product is basically the biosludge, which can be used as compost, fertilizer, and will also have water. So we can extract out the water from the sludge, and the remaining solid part can be used as compost and fertilizer. So this is basically just a brief overview of how anaerobic digestion is carried out. So some of the various reaction that happens in anaerobic digestion is as follows. So we have our organic compounds, which are basically carbohydrates, fats, and proteins present in our feedstocks. So first, these are hydrolyzed or hydrolyzed by hydrolytic bacteria or enzymes. So hydrolysis can also be considered as a pre-treatment step. So first, the carbohydrates, fats, and proteins in the feedstock is hydrolyzed to produce simple sugars, something like glucose, fructose, and so on, or amino acids, which are basically the building blocks of proteins, and then peptides. And then these peptides are then subjected to acidogenesis by acidogenic bacteria or fermentative bacteria. So in acidogenesis process, what happens is these simple organic compounds can get converted into short fatty acids, short chain fatty acids. So some of the examples of acidogenic bacteria can be lactobacillus or E. coli. And now the next step is to convert these short chain fatty acids into acetic acid and hydrogen and carbon dioxide. And this step is carried out by acetogenic bacteria through a process called as acidogenesis. And some of the examples of acetogenic bacteria are Clostridia and Acetovibrio. And now, once the acetic acid and hydrogen and carbon dioxide is produced, then a process called methanogenesis happen, which is carried out by methane producing bacteria or methanogenic bacteria to produce methane and carbon dioxide. So this is basically our biogas. So these are the various steps that are involved in the anaerobic digestion process. So just a few things regarding the methanogenic bacteria. So they are of two types basically. So these the classification is based on the reaction or the conversion of the acetate and hydrogen to methane. So the methanogenic bacteria which converts the acetic acid, which is this part here, acetic acid, those kinds of bacteria are called acetoclastic methanogens. And the other type of classification is the hydrogenotrophic methanogens, which basically converts the hydrogen and carbon dioxide into methane and water. Right. So some of the key features here is that 70% of methane is produced by this route, and these are highly sensitive and having the slowest growth rate, the methanogenic bacteria. And then this is basically for acetoclastic. So acetoclastic methanogens produce 70% of methane, and these bacteria or methanogens are highly sensitive and has the slowest growth rate. While the remaining 30% are basically by hydrogenotrophic bacteria or hydrogenotrophic methanogens, where 30% of methane is produced, and these are usually less sensitive and has a higher growth rate. So some byproducts of this methanogenesis could be formic acid and methanol. So yeah, methanogenic bacteria are unicellular, gram variable, strict anaerobes that do not form endospores. So their morphology, structure, and biochemical makeup are quite diverse. More than 10 different genera have been described. The methanogens have been divided into three groups basically on the fingerprinting of their 1,6S ribosomal RNA and the substrate used for the growth and methanogens. Basically, just just a brief classification of methanogenic bacteria. So group 1 contains methanobacterium and methanobrevibacter, and group 2 contains the genus Methanococcus, and group 3 contains other genera such as Methanomicrobium, Methanogenium, Methanospirillum, and Methanosarcina. So just different names of methanogenic bacteria that have been classified based on their RNA structure. So kinetics of methane production, one of the steps might be rate limiting among hydrolysis, acetogenesis and methanogenesis for high digestion rate. Normally methanogenesis is the rate limiting step. So basically in anaerobic digestion, as I said, there are 4 steps here. The first step hydrolysis followed by acetogenesis, then acetogenesis and methanogenesis. So a rate limiting step is one which is the slowest step of the process. So whichever is the slowest step of the process, that step is basically what determines the overall rate of the process. And generally this rate limiting step or the slowest step is the methanogenesis. If the cellulose content in the feedstock is higher, hydrolysis may be the rate limiting step. On the flip side, if the presence of lignin is higher, the rate of hydrolysis is decreased. So higher lignin content will decrease the rate of hydrolysis of the feedstock. And then transfer of the gaseous products to the gas phase may also be the rate limiting step for some of the cases. But in general, if the cellulose content is higher, you can consider hydrolysis as the rate limiting step. While if nothing is mentioned, you can even assume methanogenesis is the rate limiting step there. So that was what was taken for anaerobic digestion, and next comes the chemical route, which basically focus on transesterification reaction. So what is transesterification process? So during the process of transesterification, an alcohol such as methanol reacts with the triglyceride oils contained in the plant oils, animal fats or recycled greases to form fatty acid alkyl esters. And these fatty acid alkyl esters are called as biodiesel. And then the other byproduct of this process is glycerin or glycerol. The reaction requires heat and a strong base catalyst such as sodium hydroxide or NaOH, potassium hydroxide KOH, and the simplified reaction mechanism is as shown here. So there is a bond here like this. This is called as triglyceride. So this triglyceride will react with methanol under the influence of a catalyst, alkali catalyst or a base catalyst, in order to form fatty acid alkyl esters or fatty acid methyl esters, which is also called as biodiesel, and the byproduct glycerol. So this is basically what a transesterification process is. So basically what we are doing is we are cleaving this bond here in the triglyceride and forming the biodiesel, and the methanol will form methanol sorry so we are cleaving this bond here in the triglyceride using methanol and alkali catalyst to form biodiesel and glycerol, right? So yeah, so as I said, this plant oil can contain triglyceride as well as one more thing which are called as free fatty acids. Right. So the major part of the plant oil usually will be triglyceride, and the minor part is the free fatty acids. And some of the free fatty acids that are usually seen are, it can be either saturated fatty acid or unsaturated fatty acids. And usually these fatty acids, saturated fatty acids could be lauric, myristic, palmitic, and stearic acid. And out of these four, stearic acid has the highest melting point. On the flip side, you have unsaturated fatty acids, which means it has a double bond or a triple bond. So here, these acids, fatty acids, have double bond. So that is why they are unsaturated. So saturated fatty acids will only have a single bond or alkane bonds. So unsaturated fatty acids could be oleic acid, linoleic acid, linolenic acid, and arachidonic acid. And usually these fatty acids will have a much lesser melting point compared to saturated fatty acids. So this is basically a schematic for the transesterification. So you have the organic waste such as the plant oil, or waste cooking oil, and you can even if you have plant remains or plant seeds, you can extract the oil from the plant seeds to produce the oil, which can also be used for transesterification. And you have recycled grease. So all these feedstocks can be can be subjected to transesterification reaction to produce the biodiesel. So why do we need? So if we have oil from plants, why do we need to upgrade it by a transesterification process in order to be used as a fuel? So one reason is that the plant oil is much more viscous than conventional fuels like diesel. So it is 11 to 17 times thicker and viscous compared to diesel. So that is one major reason why we need to upgrade this plant oil. Plant oil also has very different chemical properties and combustion characteristics compared to those of diesel fuel. And if the fuel is too thick, it will not atomize properly in the internal combustion engine. And when the fuel injector spray it into the combustion chamber, it will not combust properly. So basically, it will lead to a lot of inefficiency in the diesel engine if we just use this oil as such without upgrading it to produce the biodiesel. And the injectors may also get so coked up, leading to poor performance, higher exhaust emissions, and reduced engine life. The waste oil or cooking oil and recycled grease also lose their properties and require recycling and reuse. So basically, transesterification process improves the overall quality of these feedstocks, which are basically the waste cooking oil and recycled grease, and imparts fuel properties to this oil. So that is why we need to upgrade these plant oils in order to get a much more cleaner and efficient fuel. A generalized flow sheet for biodiesel production. So let's say if you are using vegetable oils, you can directly start with the transesterification process. But if you are using something like a recycled grease, you will need to first use acid, something like a sulfuric acid and alcohol mixture to first perform a dilute acid esterification to produce the esters, and then you can perform the transesterification reaction using alcohol, such as methanol and KOH or NaOH catalyst to perform the transesterification reaction. And once the reaction is complete, you can separate the products to produce crude glycerol and crude biodiesel, from which once you refine the products and remove the impurities, basically you can get refined biodiesel and refined glycerin. Okay, so this is just a brief flowchart of how transesterification process is being carried out. So yeah, so that was about the transesterification process. Now the next conversion route is the physical conversion route, which as I mentioned is basically densification of biomass. So what is densification? So densification is the process of increasing the density of something. So in this case, if we have grass or any agricultural residue, usually the bulk density of these, agricultural residues will be much less. So it is not efficient to transport these agricultural waste just as such, because it takes up huge amounts of volume, because the bulk density of these wastes are very less. So in these cases, what we do is we apply pressure and compress it in the form of either pellets or briquettes or even boxes in some cases, and then transport it. So this way, because the density is increased and the mass remains the same, the volume is highly decreased and it is much more easier to transport. So densification is the process of increasing the density of something, and densification of fuel makes the fuel denser and gives more uniform properties with respect to its raw form. Okay, so some of these steps involved in densification can be compaction, compression, concretion, and concentration. So basically, all these process leads to an increase in the density of the feedstock. Some of the advantages of densification includes, simplified mechanical handling and feeding of the feedstock, uniform combustion in boilers, reduced dust protection, reduced possibility of spontaneous combustion in storage, simplified storage and handling infrastructure, including transportation, thus lowering the capital requirements at the combustion plant. And yeah, the transportation is mentioned here. Reduced cost of transportation due to increased energy density. Some of the disadvantages of densification is that, the major disadvantage to biomass densification technology is the high cost associated with some of the densification process. So usually we need to have some sort of equipment in order to densify the biomass, and usually the capital cost of these equipments could be high. So that is one disadvantage of densification. So yeah, so as I said, the densification, the end product, you can either get briquettes or you can get pellets. So the resulting product is called briquette if it has a diameter greater than 30 mm, and if it is less than 30 mm, it is usually called as pellets. Right. Yeah, so that is basically it for physical process. Now we move on to thermochemical process. So thermochemical process, as the name suggests, thermal means heat, and thermochemical basically means we produce heat in order to induce chemical changes. So not much details have been discussed regarding thermochemical process in this lecture, but I'll just give a brief overview of this. So as I said, thermochemical process basically means we supply heat in order to bring about a chemical change in the feedstock. And basically there are four types of thermochemical processing: combustion, gasification, pyrolysis, and liquefaction. Right. So combustion is basically, you just burn or oxidize the feedstock in presence of O2 or excess O2. And the major product you usually will be carbon dioxide and water, like fully combusted products. Gasification is also pretty similar to combustion, but instead of having excess O2, we'll be supplying it with partial O2 or less than the stoichiometric requirement of O2. And what happens is, because the O2 is less, partial combustion takes place here or gasification takes place here, and the major product could be CO along with something like CO2, H2O, or even H2 in some cases, hydrogen. So this is called as gasification. And then you have pyrolysis. So pyrolysis is conducted in inert atmosphere, or you can even use nitrogen or argon atmosphere, basically inert atmosphere, and we basically liquefy our feedstock to produce liquid fuels. So that is basically what pyrolysis is. And the final one, liquefaction. Liquefaction also produces liquid fuels, but usually these are conducted in the presence of solvent in an inert atmosphere. So one of the most commonly used solvents are water and low alcohols like ethanols and so on. But water is actually the most widely used solvent in liquefaction. Sometimes liquefaction carried out in the presence of water is called as hydrothermal liquefaction. So yes, so these are basically the four different types of thermochemical processing in order to convert the biomass into fuels and chemicals. Right. So yes. So that is what's taught for this week's lecture by Professor Mandal. And what we'll do is we'll try to solve some previous year assignment questions. And again, these are pretty straightforward actually. And we'll see what happens after that. But before moving on, any doubts regarding what we just went through for this last half an hour? Okay, fine then. Which of the following municipal refuse components has the highest moisture content? Yes, please, you can type doubts if you have any. Yeah. You have the lecture material. No, actually, I am also taking it from the NPTEL website only. So, yeah. So, I'm just basically just taking snapshots of the lecture by Professor Mandal and using it for this live session. Can you refer? Yeah, I'll just post the link here if you want. Yeah. So basically, these will have the video lectures of this course. This is an 8 week course actually. So you will have 8 chapters or 8 weeks of lectures available in the NPTEL website. Mhm. Lecture 39. Okay. Is there a 39th lecture? Yeah, energy conversations. Right. Right. Yes. Okay. Right. I might have to refer, but okay. Go ahead. Okay. Hmm. Might have to refer, but yeah, just ask me this doubt if it is possible. I'll explain it now. If not, you can just email me this problem. I'll refer and get back to you because I think I didn't go through this tutorial problem actually as of now. But yeah, sure, I can always go through it and explain what. Yeah, I'll just type it here. Yeah, this is my email ID. So you can just email me this problem. Yeah, okay. Payback period calculation is not clear. Yeah, sure. I'll just go through it and I'll try to like explain it to you. But yes, I'll have to go through that questions because like I haven't gone through any numerical question from this lecture actually. So yes, I'll just go through that and okay, if possible, I can just check what. Okay, this question. Okay, right. Yeah, I'll have to. I'll just go through this, and let you know. Sure. You found the question. I'll just go through it and I'll let you know. Okay. For the time being, we'll just get back to this assignment. Fine. Which of the following municipal refuse components has the highest moisture content? Yeah. So garbage had approximately 70% moisture content according to that table that we just saw. So garbage would be the right answer here. Which of the following municipal refuse components has the highest heating value? So highest heating value basically means lowest amount of moisture. So yeah, I mean it's actually close, but usually the wood boxes and scrapes will have much lesser moisture content compared to live bushes and branches. So usually this will have slightly higher calorific value compared to bushes and branches. So the right answer here is wood crates, boxes, and scrapes. Which of the following process is not a biological conversion of biomass to energy? Okay. So biological conversion basically means anything that uses microbes is a biological conversion. So even though microbial fuel cell we have not learned it in detail, it still uses microbes or microorganisms. So this is actually a biological process. And fermentation is also a biological process, and anaerobic digestion is also a biological process. While transesterification is a purely chemical process. We don't employ microorganisms there. So transesterification is the right answer. Okay. So which of these species are acidogenic bacteria? So if you remember correctly, this Clostridia and Acetobacillus are basically acetogenic bacteria, while Lactobacillus is the only acidogenous genetic bacteria. So the right answer here is Lactobacillus. Right. Fine. Identify the correct statement regarding the kinetics of methane production. Presence of lignin decreases the rate of hydrolysis. Transfer of gaseous products to gas phase cannot be the rate limiting step. Presence of lignin increases the rate of hydrolysis. And if cellulose content is lower in the feedstock, hydrolysis may be the rate limiting step. Yeah. So in all the four statements, these three are actually false, and this is the only true statement. So the right answer here is presence of lignin decreases the rate of hydrolysis. Dash and dash precludes the growth of methanogenic bacteria and thus reduces methane production. So methane production basically depends on the pH and the retention time of the process. And usually, if the pH is very low, and the retention time is also very low, it precludes the growth of methanogenic bacteria and it reduces the methane production. So the right answer here is option D, low pH and short retention time. Identify X and Y in the picture. So this is the picture of transesterification process. Identify X and Y. Yes. So X is vegetable oil and Y is recycled greases. So the right option here is option C, vegetable oils and recycled greases. Which of the following saturated fatty acids has the highest melting point? Right. So one way we can find how a fatty acid has a highest melting point is to find the saturation first. So linolenic and arachidonic acids are usually unsaturated. Uh, right. Basically, these has double bonds. While while only stearic acid is a single bonded fatty acid. And like from the table, we saw that single bonded fatty acids usually have a higher melting point. So out of these four options, three of these are double bonded fatty acid, which means their melting point is low, while the stearic acid, which is the only single bonded fatty acid here, has a high melting point. So out of these four, stearic acid has the highest melting point. Right. In biodiesel refining, biodiesel once separated from glycerin goes through a series of cleaning up or purification processes in order to remove which of the following components? Yes. So we have to remove both excess alcohol or methanol that we are introducing, as well as the catalyst, which could be NaOH or KOH. So you have to remove both excess alcohol as well as residual catalyst. So the answer here is both A and B. Yeah, that's about it from this week's lecture actually. But yes, you do have my email, right? You can just email me the doubt. Just remind me to like help you with it. I'll go through the question and I'll try to help you solve that question, solve your doubt basically. But yes, this is it for this course actually. Technologies for clean and renewable energy. So we have concluded like 8 sessions for 8 weeks of this course, and I think within the next 2 or 3 weeks you will be having the exam also. So yeah, all the best for the exam if you are attending the exam, and I hope these sessions were somewhat useful for at least some people. And yeah, you can always reach me through email. Exam is on 24th. Okay, good. So basically 1 week from now. Good, good. Um, Prepare well. Do well. I wish you all the best. Yeah, you can always reach me through email if you have any doubts. I'll be more than happy to like help you solve the doubts. And yeah, thank you for joining. And yeah, all the best for your exams.